Okay, YouTube, in this video we're just going to continue to practice how we can use tables and graphs with our graphing utility to evaluate some limits here. And so looking at a couple of limits, starting with this one here, we say estimating the limit here of this rational function as x gets really close to 1, we want to use both tables and graphs to support our conclusion. So let's go ahead and do this. Before we do anything here, we'll go ahead and construct a table of values of x and y. And what we're looking at here as x is getting really close to what? Well, 1 here. What are our y values getting really close to? So we'll just go ahead and partition this table here, and what we're going to do is get really close to 1 from either side. So I suppose that this would be 1.001. Okay, let me try to rewrite that there. 1.001, we'll go 1/100th above 1, and we'll go 1/10 above 1. And then going down by hundredths, this would be 0.999. This would be 0.99. Of course, we have 0.9. So let's go ahead and throw this in our graphing calculator here, starting with our numerator expression. And what we end up with is this x to the third power, so x to the power 3, minus x squared, plus x minus 1. All of this divided by now x minus 1. So x minus 1, one thing you might notice is if you actually try to plug 1 into this function, you get 0 over 0, or you get indeterminate form. So as we look at our table here, we'll go to table set. We should start our table at the x value for which we're evaluating the limit. So starting at 1, because we want to know its behavior around 1, and we'll go by 1/10 of an increment of distance here. So if I now open up my table, I suppose what we see here is that it's literally undefined when x is equal to 1. But that's not to say that our function doesn't still get really close to a single y value here from both sides. So when we look at 0.9, looks like 1.81, and 1.1, 2.21. So we have 1.81 and we had 2.21 respectively for 9/10 and 1.1 there is respectively. So as we go back to window, we'll go ahead and reset this so that it starts at 1 again. But this time we want to go by increments of 100ths. So we'd say, going back to our table here, we see that at 1 we still have this error, but at 0.99 we have 1.9801. So 1.9801. And then going over to 1/100th above 1, here we have 2.0201. So 2.0201. Now, getting really close to 1 from either side. So going back to table set, starting at 1 again, but going by 1,000th. Then we would say that we still have that error at 1, but we have 1.998 and 2.002. So 1.998 and 2.002. Suppose we've got to look at this as what are our y values getting really close to, as x is getting really close to 1, and what we can witness here is that it's getting very close to 2. So again, what we'd like to do is also support this graphically. If we hit graph here, what we could see is that we get this thing that looks like a quadratic function, interestingly enough. But we're saying where x equals 1, if we hit trace, okay, and we go to x equals 1, it's going to say it doesn't even have a value there. But as we go to the right of 1, we can see our y values as we get closer and closer to an x value of 1 from the right, they're getting close to 2. And as we go to the left of x equals 1 here, and we start to come back to the right, they're getting really close to 2 also. So just to get a better view, let's go ahead and go to zoom. We're going to zoom in, and we're going to zoom in around the portion of our graph here. You notice my little zoom cursor, where x is equal to 1, so that I can see it a little bit better. So as I zoom in, and we go to trace again, what we know is that there's a hole in our graph, okay, at x equals 1. But as I come into to 1 from the right side, so as we're coming in here, we can see, look at your y values here, they're getting really close to 2. And again, coming in from the left, we get really close to 1 from the left, we can see our y values are approaching 2. So let's take a look at this next function here, which actually, interestingly enough, is a piecewise function. But this piecewise function here, as we graph it, we see that it behaves in 2 different ways. So we say find the limit of this function as x approaches 3, where f is defined as this. So let's start by this. Let's write our limit. And our limit is the limit, okay, of f of x as x gets really close to 3. So what we can see here is that our function here, it looks like f of x equals 2 as long as x is not equal to 3. But the moment that f of x is equal to 3, it'll equal 0. So we have 2 different rules here. And what we're going to do is we're going to graph both of them. So in terms of graphing these, this is a little bit different because we're not going to be able to put this piecewise function into your TI. But what we can do is we could say that f of x equals 2. That's just a horizontal line at a height of 2. And this is true for any x value on our graph that isn't 3. So as long as we're not at 3 right here, then our graph would be at a height of 2. I suppose what we could do is we could put an open dot when x equals 3 at a height of 2. And what we could do is we could just draw on the rest of this line right here. So we say that our graph looks like this, but when x equals 3, it looks like it's at a height of 0. So we would say that it's just at a height of 0 when x equals 3, but it's at a height of 2 everywhere else. Now, assessing the situation here, we're saying that the limit of this function is the y value that our function is getting really, really close to, as x is getting close to another x value. So just really quickly, I suppose I forgot to write our limit up here. We say the limit was 2 because our function was getting really close to 2 as x gets really close to 1. Well, what do we observe our graph is getting really, really close to a height of from either side of an x value of 3 here? So as x is getting really, really close to 3, what is the height of our graph approaching from either side? And I suppose we could say that because it's approaching a height of 2 from the right, and it's approaching a height of 2 from the left, then our limit here is just 2. So we say the limit of this function is 2 as x goes really close to 3 because that's the function value that we're getting really close to as the x values we plug in are getting really, really close to 3. So what we're starting to see is that we can have graphs that have holes in them, but it doesn't matter as long as we approach the same y value from both sides of our function at a given x value, then the limit exists as a single number. Cheers.